Now then, it's been quite a busy week. Last week I went over to Steve's up in the Lincolnshire Wolds and came back with all that hoard rescue. So that was interesting. I hope you enjoy that video. And then Lee popped in Monday and he brought an Aurora inverter and we did some experiments, and he took away some of the stuff that came from Steve's from the hoard, which was great. He also took a few bits that Owen had brought down. Owen brought me some lithium phosphate batteries. Thank you, Owen. That's boots, Owen. And in amongst that there was a couple of motorcycle lithium phosphate batteries which have gone to Lee. So came from Steve, came from Owen, went off to Lee. And Lee's brought this along with a few other bits. And then another viewer, subscriber, called another Steve from Derbyshire. He got in touch with me about, I don't know, maybe a month ago, and it's taken a while to sort of filter through and anything. Anyway, he popped in yesterday it was, and he brought me some inverters, and then he took away those 110 volt SDS drills and an arc welder and a few other bits. So things is moving around and being recycled. But as for today, we've got an Aurora and a Solar River, and I'm going to test them. So we've got the test rig out. So let's crack on, shall we? Okay, so we've got the front off, and I'll just talk you through this. We've got a variac there, which as you turn that knob, it adjusts the AC voltage out. So it's a variable auto transformer. It just changes the voltage. And then that feeds into this isolation transformer, which is 110 to 240, but I'm putting the output of the variac into the 110 side, so we're doubling the voltage, and it's an isolation transformer. And then, can we see? Hopefully we can see. Let us just, can we see? We can. There's a rectifier, and that is a capacitor, and it's across the rectified DC, because if you take AC and rectify it, you still get little lumps in the signal, and the capacitor smooths it out. And then the output of that, just kick the tripod, then the output of that goes to there. That's the input. So we're going to put about 140 volts or something like that into this inverter and see what happens. So I'll move the camera so we can look at the screen, and then I will turn the variac up. So I'm just turning the variac up, and we've got something happening. We've got a bit of reflection here. We're going to continue with reflection. Oh, that's a bit better, isn't it? Okay. So we got 240 volts going in. That's the mains. It's measuring the resistance, 20 megohms. Next connection, 33 seconds. The grid is 242. We're just going through it all. Shan't be more than a second or two, and then we'll see whether it fires up. I suspect it will try and fire up and then go, no, I don't want to do this, and come up with a code. Again, it will be probably the ubiquitous E031, but we know how to fix that. Ah, yeah, I can hear some error, E031. Okay, and that's quite a bad one. So we know how to fix that. Not a problem. It's the relays. Let's just check out the Solar River. We'll just turn the, there we go, let me come out of there. That was bad arcing, wasn't it? We'll just turn the variac down to nothing, therefore there's no DC, and I will disconnect all this lot. Okay, we'll crack on with this one, but before that, anybody who's got any of these, which are the Aurora front covers, yeah, let us know, because Owen needs several of them. So give us a message, and no doubt Owen will watch the video and he will contact you. That's Owen of Boots Owen. Right, if you can do that, that would be wonderful. Now on these Solar Rivers, and I quite like these Solar Rivers, there are screws on the back, on the side, sorry. So we'll undo those screws, because it's got a strange sort of main socket, and I haven't got a plug to fit that, and I don't know which is the live and which is the neutral, because if we did, we could just stuff the wires in there. Let me just investigate, and if I need to take the top off, I'll just take the top off and then get back to you. Interesting, there we go. We've got live and neutral, so we don't need to take the top off yet, and the bottom one's the earth, and it looks like we can just put the cables in there gently. Yep. Let's see what the specification of this inverter is. Yeah, it's a 3 kilowatt, starts at 100 volts. Yeah. Right, okay, 100 volt start, 3 kilowatt. Right, let's give it a test. Okay, isolation fault. Yeah, almost instantly. So that's an internal isolation fault, so I don't think we can do anything about that. I have tried to hunt these down. If you get an isolation fault when it's attached to panels and it's been incredibly damp, then it could be in the panels, but not in this scenario. Yeah, it's just, no, it doesn't like it. I'll just attach the earth. And see if that makes any, it does. Alright, so on these Solar Rivers, they insist on having the earth connected. Well, there you go, that's a little bit OCD, but never mind. Hopefully we can see that. Yeah, we're checking. Yeah, 16, 15. I'm just going to turn this variac down a little bit. We don't want it to come in with a big load. So Solar Rivers need the earth connected. That's interesting. Normal state. Right. Okay. Right, let's turn that down to so it's not giving the variac loads of grief. Now, what I'm interested in here is if this figure here, the output stays reasonably stable. Okay, it's going up. Okay, I think we've got a tracking fault. What tends to happen is the tracker goes wrong and it puts more and more and more of a load on until it goes nah, and that's it. I've seen this so many times. It's the tracking software. Alright, well, maybe 44, 48, 51. Yeah, it's just going up and up. Oh no, well, maybe it's stabilized. Can you see that? It's at 150, 153, 151, 150, 148. Oh, it might be alright. So there was two potential faults there, and neither of them have come to fruition. But that is, maybe the inverter just needs to settle itself down. It's been chucked around and moved from pillar to post and moved counties and all that sort of thing. Yeah, 137, 6, 7, 6, 5. Yeah, maybe it's found its way now. Okay, so we've got one potentially good, but the tracker is floating quite a bit. And the other, the Aurora, we've definitely got a relay fault. So I'm going to write. I'm not going to write on this. I'll put a label on this going OK. But what I'll have to do is put it on some panels and leave it there for a week or two, just to check that it's running smoothly. But it looks like it's settled down now. Yeah. Okay, great. Let's have a look at the Aurora then. Let's have that top off. So here's the Aurora, and you've got to take all the screws out the back. Yeah, first thing. Okay, and there's some slightly longer screws, and I think they're at the bottom and at the top. So I'll just crack on with that. So that's all the screws off. Yeah. Now we have to remove those and those and their posi. So where's the posi screwdriver? There we go. It's a bit sticky in here somewhere. Just round the outside there where that seal has been. It's as if the seal is breaking down. So those two screws hold the fan in place. So this lifts up. Now let me just remind myself what's going on. Oh yes, we need to remove these. Okay, so black, red, yeah. So they come off. Yeah. And then we have this ribbon. Okay. So don't undo both ends of this, because I have a feeling that is handed. Yeah, I might be wrong, but I've got a feeling it is. And if you take it off, you can put it back on the wrong way round. Right, so now we'll undo all these screws here. Can we see? Yeah, just about. Alright, so that's all the screws out of there. And hello, we've got a couple of cable ties there. So we'll just cut those. get in there. There, done it. Okay, so this should lift up and over there. Ah, right, okay. Now we can see the problem. Yeah. Let us just move in and down and zoom in. There we go. That one there, and that one there, and that one there. Okay, so you need to scrape around those. You can either take the relays out, which is sometimes a better thing to do, yeah, or you can scrape those around there and solder that back up. But basically the heat has come from the arcing contacts. Yeah. So what are we going to do? Let me have a look. Right, we're going to zoom out. We're going to zoom out. Yeah. And it is... Where is it? It's that. So it's that one there. Well, do you know what? There doesn't seem to be any marks of heat on that case. Yeah. So I think I'm going to resolder those and then cut that top off and re-profile the contacts. Yeah, I can feel that moving. So it is that one, and there's one there which is that one. Yeah. So this one and this one. I'm a bit nervous about, let me zoom down now. I'm a bit nervous about taking these relays out if I can avoid it. Now I need to be there, because these tracks are really thin, yeah, and you're very easy to damage them by removing those pins. Very easy to damage, yeah, even with a solder sucker and everything. So I'd prefer to fix them the way I prefer to fix them. So that one there, I'm just going to scrape around it, yeah, and then resolder it, and I will get back to you during the resoldering process. Right, the soldering iron, and a big soldering iron, is good and hot. I'm going to put plenty of solder on this, and I've scraped some of the track. Doesn't quite want to. There we go. There. There we go. Okay, then the next one. You just got to get plenty on there and clean the pin up and everything like that, and spread the solder everywhere. That one's not very good. I'll go back to that one. In fact, it's not very good at all. There. Get it good and hot. I scraped these down and wire brushed them, but you've got to get it really good. Hello? Yeah. Hang on a minute. Okay, so that was those solder joints done, and I've put this back on there and put the screws in. So I've identified the relays that are a bit duff. Well, it's not duff relays, it's duff contacts. So I tend to just go round here like that, yeah, and cut the top edge of this relay. I'll do one noise alert and then I'll get on with the rest. Right, I've got a screwdriver somewhere. This one will do. Okay. So you've got to do this because the cases are glued on. There we go. And it's this end you want to get to. Okay, well that contact doesn't look bad, but I can see that it's not actually. Yeah, now I've done a video about this, okay? So let's just I'm not sure how and it happens with the solar rivers as well. What you've got, I wonder if I can do this. Let me just sort of see if I can zoom in. Okay, you've got a steel pole there which is part of the electromagnet, yeah, and when it energizes it does that, but the contact which is in here it wants to make before this piece hits that steel, and in this case it's not the case, yeah, there's no spring, right? So we want a small screwdriver, yeah, and I'm getting into this side to that contact, and I'm just bending it slightly. I might have bent it too much there, but what happens is then that's when the contact makes, and then the electromagnet pulls that steel in, so it's really pressing those contacts together. Hopefully that makes sense. I might have gone just slightly a bit too much. And then it pushes. Yeah, that's good. Okay, so I'm going to do the rest. There's actually no burning on that, but it was just doing that. Okay, right. Hopefully you saw that. You probably didn't. And it just does, the contacts just do, oh, I'm not quite sure. Whereas you want it to go, Alright, right, I'm going to crack on with the rest of those. Right, those three done, and actually the contacts didn't seem too bad at all. So I'm actually suspecting the solder joints, because normally you would have sort of burning on the contacts, and it's next to impossible for me to show the contacts. I think, yeah. Let's just see if we can get even closer. There we go. Right, so we got it. Contact, and then the plate presses a bit more. Yeah, right. And if you see, they're really quite bright in there. Yeah, right. So that's all back together. The 4 screws are on there. So the next thing to do, of course, is to flip it over, attach the cables, and give it another road test. So we've improved the solder joints no end, and we've checked the contacts, and it wasn't so much the contact burning, it was the contact fit. Yeah, so that they don't press together enough. So let's just I'll get back to you when I've set it all up for test. So the DC inputs are all connected now. The mains is connected and the MC4s are connected. Yeah, so now all I need to do is turn the variac up. There we go. Well, we've got some action. 53, 52. Right, we'll just let's just see how we go. 50 hertz. The resistance to earth 20 mega ohms. Right, we'll just hang on a minute and we'll get back to you when it gets down to 1 or 2. Well, that's different. I think we're done. 18 megawatts. Yeah, it's charging, it's inverting. There we go, 172 watts, and it's just fluctuating a bit as the tracker works out what's going on. Anyway, we're back to this screen and it's locked. Yeah, hopefully you found this interesting. It's not that scary, is it? Yeah. Comments, discussion, donations if this allows you to fix your inverter, and catch up with you soon.